Hello, Algebra 2 students. I am making this video for a lesson on 8.01 through 8.03 because I am going to be out of the office a few days this week, and this will replace your Class Connect. So I'm going to get right to the announcements. Just a quick reminder that if you're a 9th, 10th, or 11th grader, that you will have end of the year test. That's the 360 STAR 360 test, math and reading. That should be coming up in the next, 2 to 4 weeks. Graduation is May the 16th. Congratulations, seniors. You're getting super close to your graduation date. A few reminders on when assignments close this quarter. If you are a senior only, your closing dates are different than everybody else's. Seniors, TGAs close on April the 30th. And CGAs close on May the 2nd. If you're a 9th, a 10th, or an 11th grader, TGAs close on May the 13th, and CGAs close on May the 15th. So there are different deadlines for seniors because we're going to let them graduate early because they deserve that. And so they're not going to have quite as many assignments at the end of this quarter, and so their due dates are earlier than everybody else's. This week, we're in the middle of our Unit 8 matrices. This is a built-in unit. That's why you're seeing the Khan Academy videos. We are showing you in this unit how to do all types of things with matrices, and Friday is a catch-up day. Skip this. I'm going to start with definition of matrix, and I did use I don't know if any of y'all have seen the Matrix movie, but I just thought it would be cool to kind of incorporate this image here. But a matrix this is something that you probably learned, just the term matrix. Maybe they didn't call it a matrix, but they probably may have called it an array. I don't know if that rings a bell with anybody. But anytime that you take numbers or letters and you write them in rows, so our rows are going to go from left to right and our columns are going to go up and down. And I think I actually skipped this slide, which I thought was a good image. Let me go back. So just here's an everyday example. I don't know if you're like me, but sometimes I get mixed up with what's rows and what's columns. So rows are going to go left to right horizontally, like the rows in a classroom or the rows in a movie theater. And then I also thought about the eye chart. I kind of thought about something that we can imagine seeing. So the numbers or the letters, the letters in an eye chart are in rows, left to right. Okay. So those are two examples of rows. Columns, we can think about just the word column, like the columns on a house or a really big building or maybe a church. Columns are going to go up and down. Columns are going to go up and down. So I picked the Connect 4 game because the Connect 4 game can actually have rows and columns. But if we're only thinking about columns here, we're thinking about, lining up those checker circle things. I don't know what you call them. If we're lining them up to win Connect 4, in our columns, we're lining them up and down. So rows go left and right, columns go up and down. Sometimes I have to take my hand and go left to right. So in this particular matrix, and a matrix usually have these little brackets on each side, we have 2 rows. Okay, this will be row 1, row 2. And then we have 3 columns. So this would be my first column. These numbers would be in my second column. This number would be in my third column. So when we're referring to a matrix, we're going to talk about how many rows it has and how many columns it has. So it's important to know the difference between the rows and the columns. On this slide, I'm defining dimensions. So it says when you give the dimensions of a matrix, they're going to ask you to do the number of rows by the number of columns. So it's going to be R and then C. So these are not in alphabetical order. One way I could tell you to remember it's RC is because it's in alphabetical order, but it's not. So a long time ago, we used to drink a soda called RC Cola. I don't know if y'all even know if that exists anymore, but it was just a really cheap soda. So I always talk about RC Cola to help us remember it's rows by columns and not columns by rows. And some people tell me they like to remember RC as remote control. So whatever helps you to remember, it's R by C. So let me check my next slide. No, we'll do this one. So this particular matrix is the one we just looked at. It has 2 rows. So we're going to say the number of rows is 2 times the number of columns is 3. So its dimension, the dimension of this matrix is 2 by 3, meaning it has 2 rows and 3 columns. So the dimensions are really important. We're going to start talking about adding, subtracting, multiplying matrices, lots of other things. So you're going to need to know how to determine the dimensions. So on this set of problems, it says find the dimensions. So remember, we're doing rows by columns. So in this example, there are 1, 2, 3 rows. So the 3 comes first. And then you put an X, which means by, and then there's 1 column. So the dimensions for that first example is 3 by 1. This matrix has 1 row. So it's 1. That's the first number times the number of columns. It's got 1, 2, 3 columns. So the dimensions would be 1 by 3. And the last one has 1, 2, 3 rows. So 3 comes first because the rows always come first by 1, 2, 3 columns. So the dimensions of that matrix would be a 3 by 3. Number 2 is asking us to complete something called scalar multiplication. To me, this is probably one of the easiest operations we will learn in this unit. It's when there is a number on the outside of your matrix, and you take that number and you multiply it times everything inside your matrix. So 6 times 5 is 30, 6 times 7 is 42, 6 times negative 3 is negative 18. Put your brackets back around your matrix, and that is your answer. Again, negative 3, that's the number on the outside. That's considered the scalar. So we're taking this number and we're scaling our matrix. That means we're multiplying this number times everything that's in the matrix. So negative 3 times 6 is negative 18. Negative 3 times negative 2 is positive 6. Negative 3 times negative 5 is positive 15. Put your brackets back around, and then that is your answer. 5 is your scalar. We're multiplying every single thing, every number in every row, every number in every column. So 5 times negative 1 is negative 5. 5 times 0 is 0. 5 times 2 is 10. 5 times 0 is 0. 5 times 4 is 20. 5 times 7 is 35. 5 times negative 3 is negative 15. 5 times negative 4 is negative 20. 5 times negative 2 is negative 10. And there you have it. Just make sure you don't make any careless mistakes. Go back and double check. Make sure your signs are right. You're also going to be asked to add and subtract matrices. So it says when adding and subtracting matrices, the dimensions have to be the same. So that's our only rule when we're adding and subtracting. So for instance, if we were trying to add a 2 by 2 matrix with a 2 by 3 matrix, that would not be defined. So a lot of times they say defined if you can do it, not defined if you can't, or not possible. So the dimensions would have to be the same. So what I have here is I just have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 different matrices and their name. This is matrix A, this is matrix C, and so forth. And we're probably going to have some problems. Oh, no, I guess I'm just going to talk about this. So we could add A with B. So that would be defined. And I know I could add A with B because these are both 2 by 2s, 2 rows, 2 columns. Let's see what else. A and I guess I have them lined up. C and D have 2 rows and 3 columns. So I could add C and D together. And I'll show you how to add them. We're just kind of looking at, do they have the same dimensions? E and F have the same dimensions because they both had 3 rows and 2 columns. So I could add E with F. And then I could add G and H because they have 3 rows and 3 columns. And I could add U and V and W. No, I couldn't add the W. I could only add U and V because they both have 2 rows and 1 column. W has a different dimension. So you could do U plus V. So these are all of the matrices that we can add, okay? The ones that we can't, okay, that we would say that are not defined, meaning we can't do it because they don't have the same dimensions. Here are just some examples. You could not add A with C. I'm not going to list them all that we can't, but we can't add A and C because A has dimensions of a 2 by 2 and C has dimensions of 2 by 3. I could not add D with H. I couldn't add D with H because D has 2 rows and 3 columns and H has 3 rows and 3 columns. They have different dimensions. So these are some examples of what I couldn't add, which they would call not defined. All right, let's take a look at how we add. So here's an example of adding 2 matrices. Both of these matrices have 3 rows and 2 columns. 3 rows and 2 columns, so you would double check that. And then when you're adding, you're literally just adding the numbers that are in the same spot in the matrix. So you'd add the -6 and the -4. That's going to give you -10. You'd add the -3 with a -2. That's going to give you -5. You'd add this -6 with this -1. That'd be -7. You'd add this 4 with this 4. That would give you 8. You would add this -6 with this 5. That would give you -1. And then you would add this 5 with this 3, and that would give you 8. And then you would put your brackets back around your answer. So when you're adding or subtracting, your dimensions of each matrix have to be the same. And then you're just adding the numbers that are in the same location. And then putting your answers down. So number 4, we're subtracting. Remember, subtraction is like the devil and it will cause you to make a mistake. So be really careful here. Both of these matrices are 1 row and 4 columns. 1 row and 4 columns. So we are able to subtract them. So we're going to do 3 minus 3. That's going to give me -6. Then I'm going to do 1 subtract -1, and that's going to give me +2. And then I'm going to do 4 subtract -2. That's going to give me +6. And then lastly, I'm going to do 3 subtract -3, and that's going to give me a +6. Put your brackets around your answer. And then I'm going to double check myself because I make mistakes all the time. -3 minus 3 is -6. 1 subtract -1 is 2. 4 subtract -2 is 6. 3 subtract -3 is 6. Adding and subtracting matrices. Here's some problems that are just a little bit harder. Number 5. So they're asking us to subtract. This matrix has 2 rows and 3 columns. So it's a 2 by 3. This matrix has 4 rows and 1 column. So this is not going to be defined. I'm not going to be able to add or subtract because I have to have the same dimensions. So I just can't do it. In this problem, I do have the same dimensions on all 3 of these matrices. They are 3 rows and 2 columns, 3 rows and 2 columns, 3 rows and 2 columns. So this is just showing you sometimes you might have more than one operation. So remember, if we're adding and subtracting, we go from left to right. So we would start by, we wouldn't try to do all 3 of these at the same time. So just do 2 at a time and go from left to right. So we're adding. So 5 plus 3 is 8. 3 plus 5 is 8. -6 plus 6 is 0. -1 plus 0 is -1. -3 plus 2 is -1. 4 plus -2 is 2. So that's what you would get when you would add the first 2 matrices. I'm just going to double check to make sure I didn't make a careless mistake. Then you're going to bring down your subtraction sign. You're going to copy down everything in this matrix, the third matrix, just like it is. And then you're going to subtract. So you're going to do 8 minus 1. That's going to give me 7. And you're going to do 0. Let's do 8 minus 1 is 7. Let's do 8 minus 2 is 6. 0 minus 4 is negative 4. Negative 1 minus 5 is negative 6. Negative 1 minus 3 is negative 4. And 2 minus negative 2 is 4. And then I'm going to double check. 8 minus 1 is 7. 8 minus 2 is 6. 0 minus 4 is negative 4. Negative 1 minus 5 is negative 6. Negative 1 minus 3 is negative 4. 2 minus negative 2 is 4. And then this would be your final answer. So just a little bit harder because you have to add the first two matrices, get that answer, and then subtract the last matrix from the sum of the first two. Even a little bit harder here. So you see I have parentheses. So we always do what's in parentheses first. So I'm going to drop down this negative 3. This 3 is my scalar. So I'm going to multiply it times everything in my matrix. So I've got times, and then I'm going to get negative 6. 3 times negative 2 is negative 6. 3 times 0 is 0. 3 times 4 is 12. 3 times negative 3 is negative 9. And then what you do, what's in parentheses, this becomes your scalar. You'll multiply everything in here by your scalar. Negative 3 times negative 6 is 18. Negative 3 times 0 is 0. Negative 3 times 12 is negative 36. And negative 3 times negative 9 is positive 27. This will be your answer. I did want to put one that had some variables, a problem that had some variables in it. So z plus 2, even though that's two numbers, it's still one quantity. And then y plus y squared, even though that's two terms, it's still one quantity. So this is a 2 by 1. And this is a 2 by 1. So I thought that made this problem a little bit more difficult. But z plus 2 gives you one number. We just don't know what z is. So z plus 2 is not two separate numbers. It's one number, and the same thing for y plus y squared. So we're adding. So that means we're going to take z plus 2 and we're going to add it to 6y. None of those are like terms. So we're just going to end up with z plus 2 plus 6y. And we'll just leave it like that, as ugly as it is. And then we'll add y plus y squared with negative 5x squared. And none of those are like terms. So we'll just leave it as y plus y squared minus 5x squared. And then we'll put that back in parentheses. And that's how you leave it. It's kind of ugly, but that's how that one works. So that's probably one of the more difficult ones. I wanted you to see something that had some variables in it. All right, so on this problem in my parentheses, I have a subtraction problem. So I have to do what's in parentheses first because that's order of operations. And then the last thing that I'll do is I'll multiply this scalar of 3. So this matrix is a 3 by 2. This matrix is also a 3 by 2, so it is going to be possible to subtract. So I'm going to bring down my scalar for just a second. And then I'm going to get x squared minus 4y. You're not going to be able to combine those. So in that little slot, that's one slot, we have x squared minus 4y. That's one value, okay, even though there's two terms. Then you'll have 4 minus 1, which will give us 3. Then you'll have negative 5y minus y minus x. That's going to give us negative 5y minus y minus x. And we do have some like terms. We'll simplify those in just a second. And then we have negative 3x minus negative 3x, which is going to give us negative 3x plus 3x. So that's going to give us a 0. We move down to this last row. We're going to have 6y minus x. So we'll write that as one quantity. And then we have negative 4 minus 5, which is going to give us negative 9. And before I multiply by my scalar of 3, I am going to simplify. So the x squared minus 4y, that will not simplify. 3 will not simplify. These two y's will combine to be negative 6y, and then you still got the minus x. This is still 0. This is still 6y minus x, and this is still negative 9. And then lastly, we're going to multiply every single term by 3. So we're going to get 3 times x squared. That's going to give me 3x squared. 3 times negative 4 is going to give me negative 12y. 3 times 3 is going to give me 9. So remember, this is one term. If you want to put it in parentheses, if that helps you, you can. 3 times negative 6y is negative 18y. 3 times negative x is negative 3x. Remember, this is one quantity, even though it's got two terms. 3 times 0 is 0. 3 times 6y is 18y. 3 times negative x is negative 3x. Again, that's one quantity. And then 3 times negative 9 is negative 27. You're probably not going to see the parentheses here, but if that helps you, then leave them there. All right, I think we should be getting close to the end. That was it. Okay, so adding and subtracting matrices, we kind of defined what a matrix was. We talked about its dimensions being rows by columns, and then we stated that we cannot add or subtract a matrix unless the dimensions are the same. And then we talked about this number being a scalar. When you have a scalar, you just multiply everything on the inside of your matrix by that number. All right, I'm sending you the video, and I'm also sending you the whiteboard link. And this will replace your Class Connect while I'm out. Have a great day. Bye.